Okay, good morning. Let's have a class. Today's lab is pretty straightforward. It's very simple. You want to spend so much time, but there is some of the concepts we have to emphasize, especially the label. That's the number one important issue in the lab. Okay, so what we're going to do today, this is the lab 5. I would say is transfer bacteria. And also we will introduce you is a number one unknown identification. This will be one of the project you work with your bench partner to finish it and finish the report, and the due date will be 2 weeks from today. Okay, so we'll talk about that. First of all, we want to talk about the transferring bacteria. We would love to introduce you a concept called aseptic technique. What is aseptic technique? Which means transfer wanted microorganism into a fresh, sterilized medium without carry-on unwanted microorganism. And this unwanted microorganism, most of the time we refer as contaminants. So, said very easy. If I'm going to transfer E. coli into a broth medium, then there is no salmonella there. There is no environmental bacteria there. Let's say the bacteria from the bench, from your hands, and from the air. This is a very simple but very important concept, which means you're going to focus on the bacteria transferring what you wanted. Does not carry on the contaminants, because otherwise the whole bunch of the media and will be contaminated. It also could cause cross-contamination if you are talking about something in the food industry. Okay, so this is the first thing. The second thing, we would love to introduce you several of the bacterial media, what they looks like. We will talk about the detail in the lecture section today. We would love to introduce you something. Number one, you will see right here, is a very simple, looks like a little bit yellowish, brownish color liquid. This is a broth. So we talk about is a bacteria medium. So number one is bacterial broth. This is a liquid medium. Okay, obviously you know that. Now what are the components of this one? We'll talk about in the lecture. Beef extract, tryptophan, peptone, salt. Now obviously there's water there. And pH around 7, because neutral pH is fit for bacteria, optimal for bacteria to grow. So what they have? Beef extract, peptone, tryptophan, salt, water, we just say essential. Okay, lots of things. This is a liquid. Okay, now we have another two bacterial media. I would say it's agar media. We call it a solid media. What are the two solid media looks like? One is we call it a slant. Another one we call it agar. So what is slant looks like? Slant looks like this guy. Same thing, it is a melted agar you solidified. How you solidify? Put a little bit of angle there. Usually an old book, you put it there, you lay down, it will be solidified. Have this slant showing up. Okay? This is a slant. So slant, very simple to say, looks like this. Now what is the agar? Agar, you know that. We talked about in our first class already. This is the agar. The container called a petri dish. It's a solidified bacterial media. Okay, so we have another agar. Agar is like that. The container called a petri dish. Richard Petri created that. Okay. So here is the thing we want to talk about. Why we use this agar? We would love to later on, using strict plating, get single colony. Now, why we need to use this slant? This slant, we will do a zigzag streak. We want to do a very short time, about less than a month storage. So this is, we say it's a short time storage. Okay? So then we move on to something very important. Start from today, when you do any of the lab work, first thing first is label. I put 2 stars here. The idea is that you know what you're doing, you know what you put there. Otherwise, you will spending a huge time to find your own sample. Okay? So, let's talk about this label. First of all is the bloss. Let's say we have a bloss. Looks like this. Where we should label? This guy. You got to always label on the top, not at the bottom, because we want to see the bacteria growing there or not. Always label right here. Okay? So label around here. What are the information we're going to label? Your bench number. Number 1, for example. This is your bench number. Your initial. And usually we put your bacterial name. If it's E. coli, you put EC. Staphylococcus aureus, SA. Pseudomonas, PA. Agrogenisa. This is the bacterial name. Last one, put a date there. Okay? 0905, for example, put a date there. This use your Sharpie marker to do the label. Right in this area, okay, on the top. Now the second question. We have a slant where we should label. You got the label right top on right here. Right this circle, okay? So a slant, if we have a slant, we're gonna label. Circle right here. The same information, this bunch of information gonna be go there. Bench number, initial, bacteria, and the date. Now here is a question. This is an agar. You have a lid, you have a bottom. Where you should label? Can you tell me? Bottom, is that right? Yeah. You should always label at the bottom. Why? If you label on the top, the lid is gone, you fall off, you don't know where it is. and you messed up everything. Sometimes people can also label at the edge, but make sure this edge is at the bottom. The same thing. Don't label the lid at the edge, okay? So most of the time we label at the bottom. This is a very simple true or false question in the exam. Lots of people know, but in the practical life, they label at the lid. So always remember, if you have an agar, label the bottom. What are the information you're going to put there? Bench number, initial, bacterial name, and date. Very simple, right on the corner. Now here is the thing, this is going to be your bench number. I just give you an example. Not everybody write your initial is not CS. That's my initial. It happens is that I wrote this, then half of the classroom wrote like that. Then that means nothing. So that's your bench number, your initial, your bacteria, and the date. Okay, make sure this is you understand. Not everybody follow me. Then they're meaningless. That means doesn't label at all. Is that right? Okay, so you understand. You need to keep doing this whole semester because we're gonna have a lot of tubes and the broth media and the agar media throughout the semester, especially when we move to biochemistry test. You sometimes got like 7 tubes for one class. If you do not label very well, you cannot recognize it. You may spend like a half an hour to find your own tubes. Because most of the time, I will go over the results. I will say, everybody look at your tubes. Let's talk about what happened. Okay? So this is the first thing first. Very important is the label. Never forget, do anything before you're going to do label. Okay, what we're going to do today's work. Very simple for the 2 jobs. We're going to do bacterial transfer. Transfer is from the E. coli on agar. Will be the number 1 is from the agar to slant. Number 2 will be from agar to broth. And I will show you real quick how to do it. On the slant, we just mentioned we do a zigzag marker. And in the broth, you just use loop to pick, and then you put it inside. And shake a little bit. It's very simple, but make sure you do the aseptic technique. Okay, this is just you pick a bacteria and then go inside. This is pretty straightforward. Now next one, we're gonna do a project. Okay, this will be a pair. Number 1 unknown. Project. This is 15 points. Due 2 weeks. Okay, how to do it? 2 of you do it individually, but when you do the gram stain, you can work together. You will get a mixed culture like this. This mixed culture has 2 bacteria there, so it's a mixed culture. A mixed culture has 2 bacteria, which is E. coli and Serratia. It is a mixed culture. It is very interesting and very good results. This bacteria, the Serratia, grow at 25 degrees Celsius. It is red, a beautiful red color. 37 degrees Celsius, it is colorless at the top. And E. coli grows 35 degrees Celsius. Okay? So you can differentiate which one is which. So how are we going to do? First thing first is streak plating. when you get this mixed culture, the first thing first is shake. Don't forget about it. You shake. You mix it. Then how you do it? We're gonna using loop to pick the bacteria going from other place. Let me draw it. Okay, how to do it then? First of all, use a loop. In the first course is very intensively. Then you have to flame the loop. So right here, you have to flaming loop from the edge of the first course to a second course, less intensive. Then flame you loop again. Okay, make sure this is a flame loop, not to flame the agar. It's not put the agar on the Bunsen burner. It's gonna melt it. Okay, right here, you are much less intensive one. Right this corner, you flame it again. Flame loop again. And then do a last one. Okay? Or you can just do 3 course. 3 course or 4 course, it's up to you. Then we will do an incubation, which is at 35 degrees Celsius. Another one will be to 25 degrees Celsius. This will be one of you. The reason is at 25 degrees Celsius, Serosius will show red. So you and your batch partner will be incubated in a different temperature. Then what you will see? On Thursday, you will see there's some bacteria there looks like it is colorless. There is some bacteria there is red. So you're gonna describe this red colony is the colony morphology. This is colony morphology, not cell morphology. We will talk about this in the lecture a little bit. And so, which means it is round, it is punctiform, it is irregular. We look at the edge, is that smooth, is that rough? Those are the information called the colony morphology. So, is that round, for example? Is that rough? These are the things you're going to find it. And also the pigment. That's simple. Colony pigment. What is the color? Is that red or colorless? Okay, those are the things we want to talk about. Now, of course, you have that colorless colony. Okay, after we doing this, you know there is a colorless colony. It's E color. And you know there is a red color there, which is Serosia. Then we want to do is a gram stain. Now the gram stain procedure, you already know that. Is that right? Crystal, violet, followed by gram iodine, 95% alcohol, decoloration, and counterstain with saffron. And you need to tell me the 3 information. So use 10x, find a specimen, transfer to 100x with oil immersion. You needed recording the 3 information to me, which is I'm gonna write here, is gram reaction morphology and arrangement. And that will be the report for you. Now, what is the requirements of the report? You need to look at your fact sheets. The fact sheets is right here. Everybody got one. It's right here. The last page. It's very simple. The last page you can see is the procedure. Title, introduction, materials, methods, results, and discussion. You have a culture A, culture B, describe colony characteristics, cell shape, and the gram reaction. And the better you have a picture there, printed a picture, put onto use your computer. This needs to be typing. Oh, okay, very important. This needs to be typing. Now, in this chapter 8, what I wrote is Micrococcus, but I don't have that string. So this time we're using Serratia. Okay, we're using the Serratia. I'll send the email to everybody, and or put on the eCampus, and you can record it. What is that? Okay. So here is the thing. Today you're going to do the job is bacterial transfer 1, 2, and the strip plating. And this bunch of stuff right here will be due on Thursday. Okay, this bunch of stuff. We'll do the recording of the morphology of the bacterial colony, and do the gram stain will be on Thursday. And I also will say that is that next week, Tuesday, because we have a lecture exam 1, so the lab will be an optional. What means optional? If you haven't finished the gram stem on Thursday, if you failed it, that Tuesday you can come in to redo it. Some of you guys may be missing a lab and you want to come back, so I ask Ryan to also don't throw away the bacillus. If you want to come here to do the endospore stem, if you're missing the lab, you can come here to do it. So Ryan, you only need to be here is around 9:30. If somebody wants to redo the gram stem, if somebody wants to redo the endospore stem, then that's okay. Other than that, if you think it's all good, you can spend in time to prepare your lecture exam 1. So that's give you some flexible, okay? So basically, try your best to finish it on Thursday. If not, then next week, Tuesday, don't throw away your plate. You can redo it. And then, if you're missing some of the lab, you want to make it up by yourself, then the lab will be open for gram stem, simple stem, and endospore stem. It's all there. Okay? Now, next, same as before, I want to show you how to do the bacterial transfer. So everybody is coming here. I'm showing you how to do it. Let's have gloves.
Gloves there in front of the desk.
Thank you. I need some paper towel because I would love to do something first. In case if you didn't notice these things, sometimes you will see this agar plate is very wet. I would suggest you use paper towel to clean the inside of these liquid first. And the bottom. Because the Sharpie marker will be melted or sometimes faded when it's liquid there. These type of things, you also, if you see it's really wet, using your paper towel to clean it. Because that's important for the label. Okay? So what we're going to do, we will using an E. coli agar. This E. coli agar will be for transferring bacteria. This will be your homework, which is for the mixed culture of Serratia and the E. coli. First thing first is label. So let's do the label of the agar first. What's that will be the bench number, bench number 1, let's say, my initial, and this will be unknown, so I will write unknown, and date 050905. So it's going to be labeled like this at the bottom. And this is for E. coli, so it's a slant. The slant we always label around the top of the circle. So we do bench number 1, CS. This is E. coli, we wrote EC, and date we do 050905. So this looks like this. BROS always label at the top. So you can write bench number 1, CS, E. coli, and the 0905 is on the top. Okay, once you have all these things ready, we're gonna go ahead to do. So first of all, let's do the ED things, transferring bacteria. This you absolutely need a Bunsen burner, but don't need a goggle. Okay, and there's no dye there. Can I have the Okay, first thing is the same. Make sure your loop is straight. So you can use your hands to make sure this loop is straight. And the flame. Flame the loop. Let's do these one by one. Flame these a little bit. Let's do the easiest one, the BLOS. So BLOS, you have the bacteria right here. This cool down. And then pick some colony. Okay. Then put here a little finger, flame, and then go and shake a little bit. You see the reason why you have to sterilize a little bit on the top, because these metal area also going to touch the bacteria. If it's you don't do it, it will be transferring the bacteria inside. So that's all. How about slant? Slant is simple. Flame it. Kill the bacteria first. Little bit at the top. Then this cool down on the side. Okay? Then pick some bacteria. Pick some bacteria right here. Then the slant will be a zigzag from the bottom to the top. Zigzag. You don't have to break it. And then flame it. Okay. These two will be given to TA, will be incubated at 35 degrees Celsius for 24 hours. Sometimes we'll do a little bit longer. It will be 48 hours sometimes. Now we're going to do this unknown. How to do this unknown. Before we do this mixed culture, you need to shake it a little bit. You know, some of the labs, they have a vortex. You put it there, it will spin. We don't have that one, but you have to at least shake it. Because most of the bacteria are at the bottom. You see the whole turbidity shake a little bit, like 10 times, it's get ready. Okay, how are we going to do? Have your hands on with the agar, okay? So make sure it's straight. You go ahead, flame it, cool down, and touch the bacteria. You are feeling about, you can hear the voice. Okay, so go here. So first the cord is like this. Flame the loop. Cool down. From the side of the first cord to a second cord. Flame the loop. On the side you cool down. From the side of the second cord you do a third cord. Then flame the loop again. Cool down. From the side of the last cord you do a last one. And you can see when you finish, there is a marker there. And I'm not sure you can see it. If you come here to see, there is a marker there. If you go this way, you can see there is a marker there. And you knew you put the bacteria there already. And this one will be incubated for 2 different sections. And don't forget about the flame this. And the 2 sections will be One of them is we're going to incubate at 25 degrees Celsius. So I would suggest you write a 25C there. Another with your bench partner will be at 35C, so you write 35C. The 25C we're only going to put on the room temperature because that is 25C. On Thursday, you should see a beautiful red colony. And the 35C is basically for growing E. coli. Then you will see the difference. And then you pick the colony from there to do the gram stain. You're going to figure out what's the difference between them. Maybe looks similar, maybe looks different. And maybe you also could got some contamination. It all depends. But it's a good practice for you, okay? And two of you work together. I only need to turn in one lab report due 2 weeks from today. It doesn't matter how you can combine it. If you only by yourself, then you just do by yourself. Only two of you turn in one, okay? That's good. Then go ahead to do.